So first question, who here is a Java developer? Virtually everybody, good, excellent. Who has used Kotlin before? Okay, who's used, I don't know, something that they might consider similar to Kotlin, like Swift, maybe some other things like that? Yeah, okay, cool. All right, gives me a good idea about where we are. All right, so firstly, I'm going to tell you a bit about me and why I'm, I guess, qualified, I don't know, to talk to you about Kotlin. Essentially, why, like, where have I used it, and kind of how did I get here, and why am I writing things in Kotlin these days? So this is me riding a bike in London. It's not actually my bike. I'll tell you about that later. So I actually started my career working at SwiftKey. So I joined SwiftKey back in the early days. If you don't know SwiftKey, it's basically a keyboard for Android and for iOS. So it's an app you can install that replaces the keyboard that you've got. It uses kind of some very clever machine learning to do correction and prediction really, really well. So I was there for around 5 years or so. I started working on some of their native code, working on some of their Windows ports, but then very quickly became lead of their Android team. And later on moved to doing things like BlackBerry integrations, and also worked on the iOS app, which came later on. So, I mean, I've very much been a kind of mobile developer, as you'll see with some of the other things I've been working on, and that's where my focus is. So most of my Java experience is pretty much on Android, but you'll see a lot of it's quite similar anyway. I've also done some freelancing. I helped this company called Living Map build maps for Heathrow, interactive maps for Heathrow. I worked for a company called Double, who you might have seen them on Dragon's Den. They got funded on Dragon's Den, and they were building a double dating app, which was quite fun. I spent about a year or so building a kind of web-based UI testing platform, so a way to kind of smoke test your apps very, very easily with a really simple DSL. And there's a source code for all these kinds of things available on my website if you want to have a look. And then essentially I sort of started that as a company that I was hoping would kind of really take off, because I think there's a need for it. But I think it wasn't quite taking off in quite the way I'd hoped. And so I took a bit of a break at that point, and I went and lived on a boat in London while I tried to work out what to do next. And very soon, I ended up working for a company called Beeline. So Beeline's where I've been for the last year and a half or so. I've been their CTO. Beeline essentially is this little guy. It's this gadget here. It's designed for cyclists. It's basically a really easy way to get around cities. It comes with an app that works on iOS and on Android. And there's loads of kind of things that were involved in that project. You know, there's all kinds of firmware, Bluetooth. There's Firebase is what we use for a lot of the back-end stuff, for a lot of the storage, a lot of automation, all kinds of things. So, kind of managing that whole system of how all of that fits together. I have actually now left Beeline, and at the moment I'm freelancing for the Beano. The Beano, if you don't know, are a comic for kids, but they also have a website and an app where they're kind of trying to make a sort of content platform of just hilarious things, but that's just very kid-safe. It's very kid-friendly, you know, where you can't accidentally click out and it will take you onto a website where, you know, the content can't be controlled, so where parents can kind of feel fairly safe that they're going to see some fun stuff without seeing things they shouldn't be seeing. At this point, I should probably say that a lot of, well, my introduction to Kotlin came from this guy. This is Mark. I worked with Mark at Beeline. He's a really smart guy, Android and iOS developer. He kind of introduced me to the Kotlin world and also came up with the title for the talk, and I promised I'd give him a shout out. So that's him. He's got some really useful libraries if you're, especially if you're an iOS developer, but also for an Android developer, so it's worth having a look at those. But I guess this is the kind of headline of my talk, and this is kind of where what I'll focus my attention on, is that you can start using Kotlin today if you haven't done so already, and hopefully I'll try and convince you that it's worth doing, that it's worth trying out, and it's actually not too risky. So here's a simple hello world in Kotlin. You'll notice it's a bit shorter than in Java. There are a few little differences. So functions are called fun. We have some generics, as you would expect. Things are kind of the other way around. So you put the name of your variable first, and then colon, and then the type. But other than that, it looks kind of fairly similar. So the big new thing going from the Java world to the Kotlin world, and the thing that people really love about it is optional types. So optional types are great, basically, because when you're writing Java stuff, you either have, something's either, if you've got an object, it's either null or that object. And there's not really, recently there have been better ways of kind of, getting around these problems. But Kotlin actually built into the type system gives you an optional type. So you can write into the type system, this thing's potentially null or this thing's not null, and then the compiler will give you a load of guarantees based on that. You've got some slightly different syntax. So the things that you're used to writing in Java, when you normally write public final something something something, instead you'd write val. So var and val. So var is a variable that can be mutated. Val is something that can't be mutated, essentially equivalent to final in Java. But as you can see, because you don't have to write final, you're much more likely to use it and use the guarantees that it gives you, which is great. And also notice the question mark after the string. The question mark says that this type is optional. So here, the compiler will give you an error if, for example, you did val name string equals null. It will just say, well, null is not a string. Null is an optional string. So you could say var name string question mark equals null, and that's fine. But you can't assign null to this one. And the compiler does a lot more work for you than it does with Java. So this little exclamation mark, you can see over here. So if name is a variable that is an optional string, so it's a string question mark type. By saying name exclamation mark, you're basically saying, I'm telling the compiler, I know it's not null at this point, and that's essentially adds an assertion that it's not null. So your program will crash, it will throw an exception if it is. But then the compiler knows that you can call name.length afterwards. You don't have to do exclamation mark again, because the compiler has inferred that we know that name is not null, and that for the rest of that flow is known. And there's lots of nice little kind of tricks that the compiler can work out. And actually, as we move forward with different versions of Kotlin, there's more and more of that kind of inference coming in and less code you have to write yourself, which is pretty great. So, have we seen these things before? Yes. Okay. So you might, if you look at a Java code base, you might see a load of these at non-null and nullable annotations kind of dotted around everywhere. So the reason those exist is to allow your kind of linter or your compiler or sort of whatever you're using to sort of check your code to tell you, if you're assigning a null value to something and it's set as non-null, then maybe your linter can go, wait a minute, this doesn't look right. It's not going to do anything at runtime, but it means that actually you're getting a few more guarantees. What's really nice about Kotlin is it knows about these annotations. So even though say if you're using a Java library, right? You're using a Java library, and so you don't know if things are going to be null or if things are going to be optional or you're definitely going to have a value. The person who's shipping that Java library can start adding these non-null and nullable annotations all over the place, and then Kotlin automatically knows, oh, this one is nullable and this one's not nullable, so I know whether to make this a question mark type or a without question mark type, which is pretty cool. And here's something that actually, this is something that really confused me when I started using Kotlin. I kept seeing this exclamation mark type everywhere. So I've told you about string question mark, but what's string exclamation mark? So this is if you're using getString from Android by default. It has a string exclamation mark because it doesn't have an @nullable or non-null annotation. And so the exclamation mark actually means I don't know what type this is. I don't know if this is nullable or I don't know if it's non-null. So what I'll do is I'll put this exclamation mark on it, and then the first time you use it, then hopefully I'll get some inference. So if you then assign null, if you pass a null in, then automatically the compiler can know it's nullable, or you can tell it. You can say, you can cast it to optional type or to a non-optional type, and then you can use it the way you want to. But then maybe in the next version that they release this, either they'll write it in Kotlin or they'll add the annotations in, and hopefully this will disappear, and then you'll get warnings or errors if you're passing the wrong types in. Cool. So, what do classes look like in Kotlin? Well, most of the time when you're writing classes in Kotlin, they tend to look quite a lot smaller than they do in Java. And that's one of my favorite things about it. There's just less boilerplate, which is great. So this is how you write a class foo. Looks kind of the same as Java, but by default, this is a public final class. So it's final, which means it can't be extended. If you want to make it non-final, you can write open explicitly. And it's public by default. So again, most of the time, you're writing what probably are intended to be public final classes, and that is the default, which is great. And here's a really simple constructor. So notice I haven't had to explicitly write a constructor, but I've got some values that I can pass in my constructor, and they are available at various points throughout my class. So here we've got foo of type int. That's available in the constructor, in any constructor or initializer, and that value is available there. Notice bar is annotated, it has val written next to it. So a val means that that's rather than writing this dot bar equals bar in my constructor, that's essentially the val is doing that job for me. It's making that bar available all the way through my class. And notice because it's a val, it's immediately final as well. So that can't then be reassigned by something else somewhere later on in the class. And again, by default, that's public. So we can set it to private by writing private, and then this one's a private variable with an initial value of baz, which is passed in. Cool. Kotlin also has data classes. Has anyone here used auto value or anything similar to that? Yes, I've got a couple. So when you've got something holding data in Java, you'll write a class for it, and it'll have some fields in it, and then you'll have to write an equals method so you can compare it with other objects to see if it's the same. You'll write a toString method so that once you're doing some debugging, you can see what it looks like and what's inside it. You'll write a hashcode method so you can put it into a set, and you can do some kind of, you can hash it properly, and it'll get hashed sensibly. So libraries like AutoValue are essentially, so AutoValue is a library by Google. It's a Java library that essentially generates all those methods for you by just adding an @AutoValue annotation. And so you can just make an abstract class without all those implementations, and then it will make a concrete class for you. It will generate at compile time an implementation of a class. It's kind of clunky, but it sort of works. Kotlin has data classes as first class citizens. So you just write data class, and just by adding this thing data, you automatically get equals to string and hashcode, which just works, which is really good. Swift has something similar if you've used that. It's very handy. This feels kind of, it feels like we should have had this ages ago, but now we have it, which is great. So say we're introducing Kotlin into our code base. We don't want to just go, right, I'm going to convert everything. I'm convinced. I'm going to just start writing everything in Kotlin. You probably want to sort of introduce it bit by bit, or you might want to work with some libraries that are written in Java. So how do we do that? Well, let's look at a few things here. So firstly, Kotlin does not have static methods. They just don't really exist. Because in a sense, it doesn't really, and it kind of makes sense when you think about it. But anyway, static methods don't really exist, but instead you have this kind of construct called a companion object. So a companion object is an object that's associated with a class, and there's always a singleton. There's only one of them, and it just kind of always exists. And you can access it in Kotlin in the same way that you would do if you were accessing a static function. So here we've got our companion object, which has a function inside it called bar. To call it, we just call foo.bar, as you would expect if it was a static function. But we've kind of explicitly said this is an object, and it's an object that contains a function, and we've kind of been a bit more kind of specific about what it means. From Java, it actually generates a class called, an inner class called companion. So you just call foo.companion.bar, but it's still there, but it's just a bit neater when you call it from Kotlin, because you can just miss out the companion. And you can rename the companion if you want to. You can give it a different name. I'm sure I had more Java interrupt stuff, but I'm sure we can maybe come back to that. One of the things I really, really like about Kotlin is functional programming. Any fans of functional programming here? Loads, excellent. And you're all writing Java. What are you doing? If you're writing Java, you're probably using things like Guava, Google Collections, which is kind of a huge library that has a load of kind of collection methods for you, things like maps and filters and reduces, neat operations on sets, on lists, on all those sorts of things, which kind of don't exist in Java land, but you can just kind of pull a library. And the standard library in Kotlin, it's just a library that you can pull in. It's relatively small, but it has a load of these things built in. So you can start doing kind of some of your basic functional programming, and you can pass around functions very easily, which is really nice. If anyone's using Java 8, then you can kind of do Lambda functions and things like that in Java 8, and you can do that in Kotlin as well. So for me, as a mostly mobile developer, where I'm doing Android and I've been stuck on kind of Java 6 and Java 7, where you haven't been able to use those Lambda functions, being able to go, hooray, we can use them, that's great. There have been other tools for kind of like retrofitting those in, but now actually doing them properly with a proper compiler is really, really nice. So here's some slightly more functional code that if you're writing this in vanilla Java, would be an absolute pain. So let's start line by line. So at the beginning, we're saying we've got a list of 3 elements. And this 2 is an infix operator that magically creates a pair for you. So there's a Kotlin pair function, which is just a container for 2 things. So you can say 1, 2, 1, and you'll get an object with this number 1 and this string 1 inside it. It's the same with the other one, and then the final value is null. So Kotlin's type inference is now going to know that this first line, the type of that first line, is a list of optional, because there's a null at the end, pairs of integers to strings. And the type inference is just going to do that for you. You don't have to write that down. You don't have to specifically say, this is the type that it's going to be. It will just work that out. So then, because it's a list of nullable things, you have this method called filter not null available to you, which will then take out the null things if you want to. If that didn't have a null in it, this would be a list of non-null things, and then filter not null would not be available. And then you can map them using neat little Lambda functions like this. So notice there's type inference here. So the map takes 2 arguments, A and B. So A here is going to be our integer, B is going to be our string. So we don't need to specifically say what type those are. And then we have a nice little handy arrow function, and we just say, we turn the integer into a string by using string interpolation. So we have string interpolation, which is really exciting. That's new. There's so much new stuff in here if you're a Java developer, isn't it great? And then we don't have to use dot equals by default. Equals equals actually calls dot equals in Java land. So it kind of does what you would expect it to do in most kind of high-level languages these days. So you can just do equals equals b, and then this will then essentially filter out. What will be? Does anyone know what the result of that will be? I've got one at the back. It'll be what? Sorry. Map. It will be false true. Good job. Excellent. So it's a list of 2 elements. False, because that number 1 is not equal to that string that's spelled out that says 1, but this 2, when we turn that into a string, does look exactly the same as that, so it will be true. Excellent. So yeah, like I said, these methods are just built into the Kotlin standard library. It's just just a kind of Maven POM, like Gradle package, whatever, that you could just pull in, and all the stuff's available to you. It's very lightweight, and you don't have to use a humongous library like Guava. You can pass around functions. So as we saw before, we had that map function. We passed that a function to tell it what to do with the map. We can write our own. Methods that take functions as arguments, and there's some really neat syntax around how we use that. So Here is a really simple function called log, which just does a print line and adds some kind of timestamp to the beginning. So again, we've got a little bit of string interpolation here, so you can write basically any Kotlin you want inside these curly braces, and they'll just get executed as you would expect, as long as they spit out a string, or in fact, whatever they spit out, I think they're two-stringed. And notice when we call them, so imagine we have a function called readMessage. readMessage is just a method that we can call that will give us back a string. So it's a method that we can call that will give us back a string. So it fits the shape of this function f, so we can just pass it straight in. Or we have this really neat syntax for passing functions. So if your function is the kind of the last argument of your method, you can basically just miss out the curly brackets, or if you have other arguments, you can just kind of end your brackets one argument early, and then just put curly braces at the end, and that gets automatically passed in as your function value into your method. So you can see how you could actually use that to build some really neat DSLs, and in fact, there are a load of libraries appearing left, right, and center in Kotlin for sort of domain-specific languages that where you can kind of rip away a lot of the syntax, and you can make it really easy to sort of specify data structures, or animations or layouts and things like that. You can do all kinds of interesting things. Cool. So look at extension functions. Extension functions are really exciting, and I think this is yet another one of those things where people, when they start using Kotlin, get quite excited. So an extension function essentially allows you to do write a kind of static method where you'd pass. So say you have a static method where you take some data and you spit the data out in some other way. So instead, you could write an extension function where you basically say that the context of that function that you're writing it in is of a certain type. And then it just means that you can kind of write, so rather than writing a static function that says foo and it gets passed in a type, it gets passed in its parameters, you just do the type.foo. I'll show you. It's probably easier if I show an example. One of the really nice things about extension functions is that you can use generics as well. So the compiler will know when that function is available and when that function is not available based on the inferred type of the thing that you're trying to call it on. So here's one that we have. Here's a function that we have that extends lists of locations. So if we have a list of anything else, we can't call whatever that list dot total distance. That won't work. But if we have a list of these location types, then the compiler makes available to us, and our IDE makes available to us this dot total distance. So we can just do list dot total distance, and then it will just run this. So here's a really simple, very neat functional way of just saying, give me the distance between each of the two things. So zip with next is a really simple thing that's built into the Kotlin standard library. It will basically just give you a load of pairs of a value with the next value, value with the next value, value with the next value, and value with the next value. And then fold, also known as a reduce. Fold is kind of the more functional name for a reduce if you haven't seen that before. With our initial value of 0, we'll just keep adding to 0. So 0, we'll basically keep adding to this total. So initially the total is 0. The total plus current dot distance to next. So we just take each pair of locations and then we just add the distance on. Again, if you're writing that in Java, really quite painful, and then you'd probably start reaching for things like, and it's really easy to get wrong as well. It's really easy to sort of make little mistakes, and yeah, you might reach for a library like Guava or some other collections library that will do this for you. But this is all sort of built in. So I have done this talk once before, and when I did that talk, people asked me about async stuff in Kotlin. So again, one of the big headline features, of Kotlin is coroutines. So if you've used something like Go, if you've used any sort of like lightweight async thing, you might have seen some of this sort of stuff before. But essentially, Kotlin has this kind of lightweight sort of async model. I was going to call it a thread model, but it's not a thread model. built in. So a coroutine essentially is an asynchronous bit of work. So you can say, I want to run a coroutine, so I'm just going to, this is a thing that can happen in parallel with some other things. And there are various ways of saying this needs to wait for some other things, et cetera, et cetera, et cetera. So you can kind of, schedule things the way you want them to. But they're very cheap. So creating a thread is relatively quite expensive. So if you wanted to create, a million threads, that's going to quickly demolish your application. It's going to use a load of memory. It's going to, your CPU is going to be doing loads of context switching at the OS level, and it's going to be an absolute nightmare. What a coroutine will do is essentially run all of its coroutines in a thread pool. So it might run a thread pool of, say, 100 threads, and then it'll kind of share all the work out between those, and it'll work out it'll kind of schedule the execution within those threads, so that you can do a lot more small, cheap, asynchronous things all in parallel with very little overhead, which is really, really nice. So admittedly, when I started looking at coroutines, I found them, to be honest, quite confusing. And I think actually we haven't got to the point where there's a kind of accepted pattern of doing a load of different things with coroutines. There's lots of ways you can do things with coroutines, but this is an example I found online the other day, which actually I was really pleased I found, because I just didn't really know how to achieve something like this in coroutines, despite kind of reading through a load of the documentation and things like that. So this thing here called show confirmation dialog is essentially implementing a sort of promise or a future. So it's something that says, here's the thing where I want to run this bit of asynchronous code, but I want to go and get the value of it. I want to wait until that thing finishes and there is some kind of value. So here, basically, the main bit of magic is this thing called suspend coroutine. And suspend coroutine, you pass it a function, and there is a thing called resume. There's a method called resume available to you, and then you can just pass a value into resume, and essentially you end up with a sort of promise. So here, there's a little thing called launch UI. So that's some coroutine magic that says, I want to run this bit of code inside a coroutine that's on this thread, or on this thread pool that's called UI. And then you can use all the coroutine stuff inside it. I personally, if I was writing a project today where I need to do a lot of asynchronous stuff, I wouldn't use coroutines, because I think, even though I think the technology is there and all the coroutines kind of work and they're very reliable, I think just the knowledge and the understanding and the libraries around them aren't yet kind of fully formed. And actually, to that end, people have done things like, does anyone use RxJava? Yep, we've got a few. So RxJava is it's a kind of asynchronous library, and it has a load of really handy methods built in. So things like our kind of functional operators, things that will let us make, essentially it gives you a way of creating observables. So observable is kind of a stream of data. So you can say, I want a stream of data that only emits every few seconds, or I want to merge these two together, or I want to map these onto this, I want to wait until this happens and this happens. And it's got loads and loads of operators in for dealing with those sorts of things. And people have been using it for a while and been adding more and more of those operators. Doing that with coroutines is actually quite hard. And to that end, what's happened is, at the moment, some people are essentially using RxJava, but implemented with coroutines under the hood. So there's, you're putting in a fewer dependencies, but actually it feels the same to use it. But anyway, I think this is something that will kind of keep developing as we go forwards. And if you come up with any really neat ways of using coroutines, please show me, because I would love to see them. I've seen a few of these kind of examples out there, but they're a little bit few and far between at the moment. I think that a lot of theory is there, but the examples aren't out there so much. Cool. So what if you want to actually start using Kotlin now, right? So say you've got some Java code and you're like, cool, I want to give it a go. I want to start converting some stuff. How do you do it? So firstly, use IntelliJ. There is a very good reason for that. I'm sure everyone has their favorite IDEs. Mine is IntelliJ because it is actually really good. But IntelliJ is made by JetBrains. Kotlin is also made by JetBrains. So it's actually incredible. Like, this is the first time I've ever used a language that's relatively new that just has amazing IDE support, because it's written by someone that writes an IDE. So you just open IntelliJ and it just knows how everything works, and you get loads and loads of help. It will tell you, hey, why don't you convert this var to a val? Because you don't mutate it. So maybe you should change that. You get a lot of these little bits of help. You get help with things like when clauses. So a switch. Instead of switch in Kotlin, you have a thing called a when. But a when is a lot more powerful, and you can do loads more useful things with it. It'll tell you things about optional types. It'll tell you, this doesn't look like Kotlin. This looks a bit like Java. Maybe you should try using this method instead. And again, with every version of Kotlin that comes out, there's newer kind of hints that will help you to write better Kotlin. So I'd say 99% of the Kotlin I've learned is mostly just through IntelliJ, just telling me, how about you write it like this instead? And so actually, once you take that plunge, you can kind of start writing things in a very Java style, and that's totally fine, and it totally works. But it will kind of help you to write things in a more Kotlin style as you go. This is my favorite thing. It's great. So you can just paste Java code into IntelliJ, and it will just convert it into Kotlin. It'll go, hey, this looks like Java. And a little pop-up comes up saying, do you want me to convert it to Kotlin for you? You're like, yeah, sure. That'd be great. So you can find, people can send you code snippets if you're copying and pasting or off Stack Overflow or whatever you're doing. It all just kind of works, which is really, really neat. There's even a keyboard shortcut. There's a keyboard shortcut for converting a file to Kotlin. So you're just like, be like, I think maybe I should take the plunge and do it file by file. So you just hit the keyboard shortcut in IntelliJ. It'll just convert it for you, and it'll work. It does occasionally mess up. And I say that having essentially converted the entire Beeline Android app code base into Kotlin. But to be fair, it took me a few days because I had to fix a few of the things where it messed up a little bit. But most of the time, it just works, which is really, really neat. So, basically, I think Kotlin's a lot better than Java because you get shorter code, because you get null safety. Even if you're using libraries that don't give you null safety, you can specify your null safety outside of it. The Java interop is super, super easy. The IDE is amazing, and that's really what sells it to me, to be honest. And loads more libraries are being developed in Kotlin all the time. And even if there isn't one in Kotlin, then there'll be one in Java, and you can still use it, and that's great. So Google are actually really committing to using Kotlin, certainly for Android things at the moment. So not Android things, that's actually a thing on its own for Android. And you're actually starting to see code snippets come out. So if you go and look at the official Android SDK documentation, everything is, not everything, but a lot of it now is, it gives you the option of, do you want to see this in Kotlin? Do you want to see it in Java? And it's defaulting to Kotlin. So they're really, really pushing it. They also hired this guy called Jake Wharton from Square. If you're an Android developer, you will have used one of his libraries because he basically writes all the useful libraries. And specifically because he was focusing a lot of his attention on Kotlin, and his job essentially within Google is to sort of push the boundaries of let's make sure everyone's using Kotlin, and let's kind of keep going that way. So that's really, really good. So you've got JetBrains and Google kind of all working to make Kotlin very, very usable. So again, I'm a mobile developer. I've written a load of Swift. This was initially a talk for mobile developers. So I thought it's probably worth visiting, if you're coming from a language like Swift, something that's, what I'd say is a more modern, grown-up language, rather than going from Java to Kotlin, going from something like Swift to Kotlin. What does that look like? Well, here's some Swift. It's pretty simple. So it's going to take this list of numbers from 1 to 10, and we're just going to print the list of numbers that is those numbers doubled. Does that make sense? Relatively simple. Doesn't really matter what this does. Let's just look at this in Kotlin. It's almost the same, right? So go back, go forwards, go back, go forwards. Few little changes. So your func has become a fun. Your type arguments look slightly different, and your let has become a val. You can infer this type here. You haven't had to explicitly write that that's a list of ints. Kotlin's inferred that for you, but otherwise it looks pretty much the same, right? To be honest, if I was writing this in Kotlin and I got this in a code review, I'd probably look at that and go, maybe there are some neat ways we can write less code. So firstly, I do that. So notice here, I've gone from, explicit return type instead of gone from equals and then just given it an implementation. So whenever you use equals, you can just give it a one-liner that is the implementation of your function, and whatever the return type is of that line is inferred to be the return type of the function that you've just written. So we don't need to write that it returns a list of ints, it just knows a list of numbers. I've also made it inline. So inline means that, essentially it will get inlined at compile time, so we don't have to actually do the overhead of doing the context switch, even though that is very cheap on the JVM. If we're doing it a lot, inlining that sort of thing does kind of make sense. But then if we're sort of inlining this and our implementation is kind of one line, then why bother having a function for it at all? Why don't we just write it like this? It would be loads easier. So again, you can see how coming from more lower level languages to these kind of like slightly higher level languages, how neat these sorts of things are. Cool. So that's kind of all the content I've got for you, really. There's loads and loads of links out there now that are coming out every day. There's some good places on Reddit. There's a Kotlin Slack. There's the Fragmented podcast, which is specifically usually about Android, but becoming much more and more and more about Kotlin. But there's also a Talking Kotlin podcast. I haven't actually listened to that myself, but if it's good, tell me, please, because I'll be interested. And then there's these two kind of like heavyweights, I guess, in Pinterest and in Google. So Christina Lee of Pinterest is really pushing Kotlin and pushing kind of more the like why we should be adopting Kotlin side of things. And Jake Wharton's kind of really working on a load of the libraries and things under the hood that's really kind of pushing it forwards. But yeah, I think it's a really nice language. To be honest, if I had to write some Java today, I'd just shudder and go, can I please write this in Kotlin? Because I just find I'm writing less, it does more for me, and it's just nicer to use. But yeah, if you've got any questions, fire away.